So these two pages of notes go together. So make sure that when you glue them into your notebook, you glue them one on the left side and one on the right side. This is probability, and this is the continuation. So with probability, you will have either one event, which means you'll have one fraction, or you're just doing one thing, or you'll have two or more events, and these two or more events can either be independent or they can be dependent. We're going to start off with the one event here. So after you have these cut and glued into your notebook, then we'll go ahead and start off with the one event here. One event means that you will do one thing. You'll only end up having one fraction. A simple event is one event. For example, if you have a drawer full of socks and you're trying to pull a blue sock out of that drawer, what's the probability of getting a specific color that you're looking for? So let's say you need a black sock. What's the probability of getting that black sock? So you reach in and you just pull one time. The probability of one event is found by using this formula here. So the probability of A, and A is your variable representing anything that you're trying to do. So example, in this one it would be, what's the probability of getting one sock? Or like one blue sock. It's a fraction. You always start off with a fraction, which is the number of ways event A can occur, divided by the total number of possible outcomes. The probability of an event can be represented as a fraction, so you always start off as a fraction. But usually when we talk about a fraction, usually you don't, when you talk about sorry, let me back up. Usually when you talk about probability, you don't express it as a fraction, or you don't express it as a decimal. You usually express it as a percent. But to go from the fraction, you have to convert to a decimal. Then from that decimal, then you convert to a percent. So we're going to go ahead and practice all three of these because we have to start off as a fraction. That's our formula. So let's try example number 1. Example number 1 says, when rolling a number cube, what is the probability of rolling a 5 on a number cube? Well, if you look at this number cube here, let me zoom out a little bit. We're trying to figure out what is the probability of rolling a 5. You have a 1, 2, 4, 5, 3, and 6. So there's 6 sides, and there's only one 5 on this cube. So you have a 1 in 6 chance because there's only one 5, but there's 6 choices. However it is that you roll, see there it rolled on a 4, you only have a 1 in 6 chance of rolling a 5. So when you write down the formula for probability, you always start off by saying, what is the probability of whatever you're looking for? Here we're trying to find the probability of rolling a 5. So what's the probability of rolling a 5 on this cube? The top number is the number of ways event A can occur. So essentially it's saying how many 5s are there. Well, on this cube, there's only one side with the number 5. The bottom part of the fraction is the total number of possible outcomes. Well, the total number is, there's 6. It could land on a 3, it could land on a 1, it could land on a 4. So there's 6 possible outcomes that it could land on. So you have a 1 in 6 chance of landing on the number 5. So we'll go ahead and we'll convert this to a decimal. 1 divided by 6 on your calculator. And 1 divided by 6 is 0.166. It's a repeating number. And usually when we talk about probability, like I keep saying, it's usually expressed as a percent. It can be all three of them, but percents make most sense when it comes to probability. So we're going to move our decimal 2 places to the right, and it would be a 17% chance. And the reason I say 17 is because this 6 makes this 6 round up. So this would be 17. So there's a 17% chance of landing on the number 1. So looking at the likelihood scale, 0.16 or 17% would be way over here from 0 to 100. So it's unlikely that we would go ahead and we would land on this 5. It's not that it's impossible, it's just unlikely that it's going to fall on that. Example number 2, selecting a girl. So what's the probability of selecting a girl out of a class of 24 students if there are 10 boys? So what is the probability of selecting a girl? Well, upon looking at this, we have just the top number represents how many items there are, or how many, whatever it is the probability that we're looking for, how many items are there here. Here there was only one 5 on the cube. Here we have to figure out how many girls there are in this classroom. If there's 24 students and 10 of them are boys, that means that the rest of them are girls. So in this one we're going to have to do a little bit of calculating first. 24 boys minus 10 girls, 24 students minus 10 boys, there's 14 girls left. So the probability of a girl, there's 14 girls out of, the bottom always represents the total number of possible outcomes. There's 24 students that could possibly be pulled. So there's 14 out of 24 students in that classroom. So in your calculator, 14 divided by 24, 14 divided by 24 gives you 0.583 repeating. It's a rational number because it's a repeating number. So we're going to say 0.583 repeating. We're going to convert this to a percent, so we're going to move this decimal 2 places to the right, and we'll just go ahead and round it to the nearest whole. So there's a 58% chance. That 3 does not make that 8 round up. So there's a 58% chance of picking a girl out of this class. Looking at your likelihood scale, 58%, here's 0.5, and here's 0.6, 50, 60. So 58% would be about right here. So it's not that it's equally likely, it's more likely going to happen than it's unlikely. It's not exactly equal, but it's pretty close. But on this one we're going to say it's more likely that you're going to pull a girl out of this class than you would a boy, because there are more girls. So this one we're going to call this one, it's likely that you're going to pull a girl. Example number 3, what is the probability of rolling a 4 or a 2? Now this one might confuse a few of you. So what is the probability of rolling a 4 or a 2? Even though there's 2 numbers here, you're not trying to pick both of them. This is why this is still a 1 event. This is a simple event. You're not trying to pull a 4 and a 2. We're going to talk about ands over here. See the word and? We're talking about pulling a 4 or a 2. So on this one, it doesn't matter if we pull the 2, or it doesn't matter if we pull the 4. So long as we pull the 2 or the 4, we're going to be happy. So how many possible ways can it occur? Well, there's 1 4 and there's 1 2. So we're going to put the 2 at the top, because it doesn't matter if we pull the 2 or it doesn't matter if we pull the 4. So either one of these 2 sides, we're going to be happy. So the probability of pulling a 4 or a 2 is going to be 2 out of the 6 sides. So there's a 2 in 6 chance that we're going to roll either a 4 or a 2. So 2 divided by 6 in your calculator, to convert that to a decimal, is 0.3 repeating, 0.333. So that's a repeating number. We'll just go ahead and put the repeating there. Just make sure that you don't just put 0.3 here, and then when you move your decimal 2 places to the right, don't fill this in with a 0 here, because that would be wrong. Because it wouldn't be 30%, it's 33%. So there's a 33% chance that you're going to roll either a 4 or a 2. So it's on your likelihood scale, you have a better chance, because here's 33 over here, rolling just a 5 was over here. So it's still unlikely that it's going to happen, but you have a better chance of rolling a 4 or a 2 than you would just have rolling a 5. So, but it still does follow under this unlikely. So a 33% chance, it's unlikely that you're going to pull roll either a 4 or a 2 when you roll this. Let me roll and see what I get. I get a 3. So it's unlikely that it's going to happen. Number 4, what is the probability of rolling a heads or a tails on a coin? So looking at a coin, I don't have a coin with me. What is the probability of rolling a heads or tails on a coin? Well, we know that a coin has 2 sides. Let's pretend this is a coin. So this is heads and this is tails. So we'll just pretend this is a coin. So the top number represents how many are there. Well, there's 1 heads and there's 1 tails. So the word or means it doesn't matter what side we land on. So long as we get a heads or a tails, we're going to be happy. So there's 1 heads, there's 1 tails, so there's a total of 2 possible outcomes that we want. And then there are how many total sides? Well, there's 2 sides. So this would be, we have a 2 out of 2 chance of flipping either a heads or a tails. So we have a 2 out of 2 chance. 2 divided by 2 is 1. And we're going to convert this decimal to a percent, so we move this 2 places to the right. We have 100%. So looking at our likelihood scale, they would be over here. It's certain, it's absolutely positively going to happen that if we flip this coin, we're going to land either on a heads or a tails. So it's certain that it's going to happen. So if we flip this, and we're happy if we get a heads or a tails, we landed on heads. No matter what we flip, we're always going to land on either heads or a tails. So we have a 100% chance of landing on a heads or a tails. Example number 5. A spinner has 6 sections. 2 of them are red, 3 of them are blue, and 1 of them is green. What is the probability of spinning a red or a green? So what is the probability of spinning a red or a green? So we have to look here. 2 of them are red, 1 of them is green. So if it lands on a red or on a green, we're going to be happy. So there's 2 reds and 1 green. So there's a total of 3 that we would be happy with. So this top number is what is it that we would be happy with whenever it falls into here. The bottom number is how many total there are. So you have 2 and 3 is 5, plus 1 more is 6. You have a 3 in 6 chance of spinning either a red or a green on the spinner. So your spinner would look like something like this. Oops, that's not a good spinner. So these 2 are red, these 3 are blue, and then this one here would be green. So 3 divided by 6, you have a 3 in 6 chance. 3 divided by 6 would be 0.5. 0.5, change this to a percent, move your decimal over 2 places, and you have a 50% chance of rolling either a red or a green. And of course, looking at our likelihood scale, that falls right in the middle. It's a 50% chance. It's equally likely or unlikely. So it's not going one way or the other. It's exactly equal. It's equally likely or unlikely that you would actually spin on either a red or a green on this spinner.